Okay, so basically, this section's kind of like randomly thrown in here. It kind of goes along with some of the stuff we're doing with like, the rates and whatever, but it also is kind of just randomly thrown in here. But it's basically like if we had some sort of like big loan that we were taking out, like a mortgage or like a big car loan or something like that, they're going to give us a formula that banks typically use to give out loans, and we'll talk through that in a little bit here. So some important things that we'll need to know if they're referring to stuff. Principal is always like your starting amount, or in this case, since it's a loan, it's the amount that you borrowed from the bank or the credit union or whoever you're getting your loan from. Interest rate, we know what that is, right? That's our percentage of money that we're borrowing from whoever we're getting it from, bank, credit union, whatever, and is charged by the lender. So the lender would be the person that's giving us that money for borrowing that money. And then usually how that works is usually you pay back like a chunk of it each month, and I'll kind of show you with some of well, there's really only one example we're going to do today, but I'll show you with that example how we kind of split that up over the month, or for the months of the year. And then term of the loan is always like how long that loan's going to last. So like I said, like mortgages is a big example of this. So like a mortgage is like something you get on your house, and usually with those, they'll do like a 15-year mortgage, a 20, 30, something like that. Typically how those work is the ones that are less amount of years have a better interest rate. No, opposite way. What is it? The ones that are shorter length have better rates, and the ones that are longer have worse rates. So like if you think you could pay off your house in 15 years, you would want to go with that one. But obviously sometimes it's hard to pay something off that's that expensive in 15 years, but it's a better rate at that. But I don't think you guys are buying houses anytime soon, so I think you'll be all right. And the bank's going to walk you through all this stuff when you get there anyways. But it's good to know where the numbers are coming from, just in case like the bank's trying to mess with you or something. Not that I think the bank would, but it's still good to know where the numbers and stuff are coming from. Anyway, so like I said, there's like one formula there that we're mostly going to use. So that periodic installment formula for a loan. Basically, it's kind of a complicated formula there, but P is just our principal we're putting in. R is just going to be our rate. We just want to make sure with our rate, and that's kind of what the bullet is I've got here. We always want to take that rate and divide it by the number of payments that are happening a year. So like if you're paying off that loan monthly, you would take whatever your percentage is and divide it by 12, because there's 12 months in a year. If you were paying that loan off like quarterly, you would divide it by 4, because there's 4 quarters in a year. Does that kind of make sense? I think it's mostly monthly when we do it, but they do have kind of an example in the book that's on page like 536. They kind of talk through in this paragraph here of like breaking that percent up. So they got like a situation here that is a person supposed to buy or borrow $6,000 with a term of 36 months, so basically like 3 years, to buy this used car. Their interest rate is 9% for the whole year, but what you're going to do is you're going to take that 9% and you're going to split it up per month, because you're going to pay this monthly. So whenever you have your percentage, you're always going to divide that by, the amount of payments. So like here you can see they did 9 divided by 12, got 3.4 or whatever, turned that to a decimal, and then that would be the decimal they're using. So just be careful on that. And then they kind of just show how that breaks down. And then basically what's going to happen is each month that you do this, if you've paid some of this off, each month you're going to pay a little bit less in interest because you've already paid some of your loan off, if that kind of makes sense, okay? But like I said, mostly just the formula thing today. Okay, and there's really only one example we got to go through here, so we'll do that one quick, and then you guys will have plenty of time to work on stuff. So if you go to your example packet for the 8.6 one, we got one internet auto loan calculator. So like they have things out there that you can like go to a bank. So like I did this the other day when I was looking at stuff. I went to Fidelity and typed in like some numbers and stuff, and they use this same exact formula. They just do it for you, because obviously a lot of people are not bright enough to do math themselves, so the bank does it for you. But they basically did it out, and then we're supposed to just double check that the bank's calculator thing did it correctly. But so auto loan calculator indicates that if $15,000 is borrowed at an interest rate of 10% per year to be paid back in 48 months, or that's the same as 4 years, then the monthly payment is going to be $380.44, and then we're supposed to use that periodic installment formula, the one that we wrote in our notes, to check whether the site is using the same formula that we're using. Okay, so basically we're just checking to see if our answer comes out to that when we have that information. All right, so first thing we got to know is we got to know our principal. So that's that $15,000 because that's the amount of money that we're borrowing from the bank. And then our interest rate there would be our R value, and that's the 10. And what you want to make sure that you do here, like I was kind of talking about before, like they had in that example in the book, you always want to divide it by the amount of payments that you're doing in that year. So in this case, we're paying it back monthly. So if we're paying that back monthly, we're dividing by 12 because that's our number of payments in the year. Okay, so like I said, if it was like quarterly, we divide by 4, monthly we divide by 12 because we're paying that 10% split up over 12 months. And then realistically, when we put this into our formula, we want to take 10% and turn that into a decimal. So really it would be like 0.10 over 12. And if you use your calculator to simplify that out into a little bit nicer fraction there, it's 1/20th. And again, I just got that by typing it in my calculator, hitting that fraction button. And then the other piece of information we need to know is N. And N is your number of total payments that you're making. So again, we're doing it over that 4 years, which is going to be 48 months. So since it's monthly payments, we're going to be making 48 payments. So that'd be 48. And then you're basically just plugging into that formula they had there. So like that formula, I'll just write it down so we got it here. So it was P, parentheses, 1 plus R, and then to the power of N outside that parentheses, then the R again over 1 plus R to the N minus 1. And when I do my plugging in here, I try to leave stuff as fractions because when I was kind of going through and doing some examples with this stuff, it seems like when you round something that it really throws it off by quite a bit. So I kept it in my calculator as long as possible and left stuff as fractions if I could leave it as fractions. But I tried not to round through it because it seemed like it had a great effect on the answer when I did that. So I'm just going to start by plugging my stuff in here. So like the 15,000, parentheses, 1 plus. And again, I turned this into like a nicer fraction to use for the rate. So like 1 over 120 to the power of, our N is 48. I did forget a 0, you're right. There we go. Okay, and then our R would be the same, 1 out of 120 over, and then our bottom there would be 1 plus that same R of 1 out of 120 to the power of 48 minus 1. And I think why this is in this section is I think they do it because it's similar kind of to the geometric sequence one, where this is probably calculating out like the first term, and then this is your change per month, and then you remember how it's like minus 1 with that sometimes. I think that's why they throw this loan stuff into this chapter, but like I said, we just need the formula. So I think what I'm going to do here is I'm going to do this whole top row calculated out first, leave it in my calculator, and then just do divide by, and then do this whole bottom row out. Okay, so I'm going to type that whole thing out for the top first, making sure I include my parentheses and stuff where needed. Should probably turn the light on here. Oh. Okay, so I'm going to go 15,000 parentheses, 1 plus 1 divided by 120, and I don't need a parentheses around that because it'll pick up order of operations to do divide before add. Close my parentheses, power of 48, and then it would be times, so I'm just going to go parentheses again, 1 divided by 120. And again, probably going to get some gross number, which is fine, but like I said, I would just leave it in my calculator because when you do some rounding stuff, then it kind of turns into a mess. So then I would just take that number, and I'm just going to do divide. And then here, I'm going to go parentheses to start to group this whole bottom part together just to make sure that it does this whole first one divided by the whole bottom. So I'm going to go parentheses, another parentheses for this chunk here, 1 plus my 1 divided by 120 again. Close my parentheses, power of 48, and then minus 1, and then I'm going to close my full parentheses there again, just grouping that whole bottom together there, hit enter, and then that'll get me exact what I've got. Okay, so I ended up with that it would be approximately 380.44. And then what the question was actually asking us there is they were saying, okay, does it come out to be 380.44? Well, that's exactly what we got, right? So it'd just be yes that it didn't work out. But most of the time they're just going to ask you to calculate it. They're not going to ask if it matches, but That's kind of what they're getting at, okay? And that's it. Mostly that formula, and then just knowing what the principle is, what the term is, just a little bit of vocab, and other than that, it's just the formula. So working on this book page here for tomorrow, and then tomorrow we'll end up doing that 8-7 stuff.